Imagine an elevator so massive it can lift a 3,000-ton ship, yes, a real ocean-going vessel, straight up over hundreds of feet of dam, not a canal lock, not a ramp, a vertical elevator. That's China's audacious bet on rewiring the rules of river transport. Let's dive into world's most insane engineering push. Buckle up, it's engineering gone wild. Why would you ever need a ship elevator? China's rivers are its arteries for trade. Dams help tame flooding and generate power, but they also block navigation. Historically, dams force ships to go through complex lock systems. Think of a staircase for boats, which is time-consuming, limits ship size, and creates bottlenecks. The idea, what if you could lift the ship instead of dragging it through locks? That's the radical premise behind ship lifts. So when China invested nearly $1 billion, or more, depending on which project you pick, into a giant ship elevator, it was betting on efficiency, scale, and engineering audacity. The Three Gorges Dam ship lift. At Three Gorges Dam on the Yangtze River, China installed a monumental ship elevator. It can raise or lower vessels up to 3,000 metric tons over a height difference of about 113 meters, 371 feet. What used to take 3 to 4 hours via locks now takes just about 40 minutes. The lift is essentially a huge basin, caisson filled with water, carrying the ship within. Think of a floating bathtub that moves. That's right, the ship never leaves the water. It floats in its elevator car. How do you actually lift millions of kilograms? You might think, that must take gigantic motors, but the trick is balance and clever design. Archimedes plus gravity plus counterweights. The principle is elegant. 2 chambers, same volume, filled with water. They balance each other like identical bathtubs. When you put a ship into one chamber, the water level adjusts so the total weight stays balanced. The trick is in fine control. They use counterweights, cables, motors, and safety locks to pull the system up and down when needed, but it doesn't rely purely on brute force. Essentially, you only need energy to overcome friction, losses, and to manage minor imbalances, not to lift the full load every time. It's ancient physics at battle scale. Archimedes would be proud. Engineering challenges and bold solutions. Building a giant ship elevator is not just a matter of scale. The devil is in the engineering details. Here's what the designers had to wrestle with. Size constraints and structural strength. The basin must be long, wide, and deep enough to hold the largest ships intended. The structure must support not only the weight of the water plus ship, but also dynamic stresses, wind, seismic forces, thermal expansion, water control and leakage. Any leakage or imbalance in water distribution can cause dangerous torque or tilting, so sealing, fine calibration, and safety systems are essential. Water-saving systems are important. You don't want to pump thousands of tons of water each cycle if possible. Cable systems, pulleys, and safety. Tens to hundreds of high-strength cables, complex pulley arrangements, and redundancy are needed. Safety stops, braking systems, locking mechanisms. Every failure mode must be anticipated. Energy efficiency versus speed. A balance is needed. You want the lift to operate quickly enough to save time, but not waste energy in doing so. Because of the balanced design, energy needs are surprisingly moderate, mostly for driving motors, overcoming friction and control. Integration into the dam and navigation system. The ship lift has to link the upstream and downstream canals in functional, safe ways. Ships must approach, enter, exit, docks, guiding systems, gates, and traffic control get complex. The genius behind the design. What makes the Three Gorges ship lift so revolutionary is its synchronization precision. The system uses 36 steel cables and 112 balancing ropes, all moving in harmony to ensure smooth vertical travel. The entire 3,000-ton basin is controlled by hydraulic pressure sensors and a central computer system that constantly monitors load balance and cable tension. Even a few millimeters of tilt could spell disaster, so the system adjusts in real time to keep the ship perfectly level during its 40-minute ascent. Each operation is a masterpiece of timing and control, and remarkably, the margin of error is less than 2 millimeters. That's the kind of engineering accuracy usually reserved for spacecraft, not river barges. Powering a giant with minimal energy, One of the most surprising facts is how energy efficient the elevator is. Because the ship lift uses counterweights and gravity-assisted balance, it requires far less power than you'd imagine. The motors only supply energy to overcome friction and initiate motion, meaning it's as sustainable as it is impressive. This design ensures that every lift cycle consumes only a fraction of the power used by traditional multi-lock systems, a crucial consideration when operating year-round on such a massive scale. A symbol of China's technological confidence. Beyond its mechanical brilliance, the ship elevator has become a symbol of national pride. It reflects China's ambition to merge ancient river navigation with 21st century engineering. Standing tall beside the world's largest hydroelectric dam, it's more than infrastructure. It's a statement of innovation, proof that human ingenuity can conquer even the mightiest natural barriers. Why it's rumored to cost $1 billion or more. Massive civil works, excavation, foundations, concrete, reinforcing steel, precision fabrication, huge steel parts, hydraulic systems, cables, sensors, complex controls, safety redundancies, automation, integration into dam infrastructure, waterways, navigation channels, testing, calibration, risk buffers, high cost for just in case, land acquisition, environmental mitigation, flushing out downstream effects. In large infrastructure, cost overruns are common, and when you attempt something never done at that scale, the unknowns drive up both cost and contingency. Other Chinese ship lifts, pushing further. China isn't stopping at Three Gorges. Other massive lifts are underway or in operation. Pinglu Canal Project. China is building what may become the largest ship elevator in the world, capable of lifting 5,000-ton vessels over significant height differences. Shuiko Shiplift. In Fujian, a shiplift capable of handling 500-ton vessels. Longtan Dam will feature a tall shiplift for 500-ton ships. China is treating the ship elevator not as a novelty, but as a platform technology for future inland navigation. Why this matters beyond cool engineering. Efficiency and capacity. The new lift transforms logistics, cut massive time off river navigation, hours to tens of minutes, increases throughput of cargo, reduces waiting times, expands river route viability, environmental and energy impact, lower carbon footprint compared to building more roads or trucks or long detours. Energy usage is reduced thanks to balance and gravity assistance. Strategic and geopolitical value. Inland regions get better access to trade routes. China reinforces self-sufficiency in infrastructure, reduces reliance on external passages, creates signals of capability. Look how far we can push engineering. Inspiration and ambition shows what human creativity can do when constraints are high. Elevators for ships aren't science fiction. They're here, built, tested, and operating. Challenges us. What if we applied similar thinking to our own infrastructure? Risks, criticisms and unknowns, maintenance and durability, moving parts, water, cables, wear and tear is inevitable, cost overrun risk, mega projects often balloon, utilization risk, will ship traffic justify massive investment, environmental disruption, building such superstructures can alter hydrology, ecosystems, technological failure modes, a cable snapping or system imbalance could be catastrophic, so fail-safes must be rock solid. But the engineers know these, hence multiple backups, safety margins, constant monitoring. Why you should care, you may never board a shiplift, but it's a window into how engineering evolves when challenges are huge. It teaches us to blend old principles, Archimedes, with modern tech. It provokes question, how can we reimagine infrastructure in our own cities, rivers, lands? It's a story of ambition, building not just for today, but for generations. In one bold stroke, China has shown that dams need not be barriers. With enough creativity, audacity and precision, you can build an elevator for ships. $1 billion vessel lifter that rewrites the rules of river navigation. That is the kind of daring engineering that challenges what we think is possible. If this story fired up your curiosity just a little, smash that like, subscribe and share, because we've got more engineering wonders ahead. Let's keep pushing our imagination.